Hi guys, how you doing? So I'm just finishing up 7.2 right here. So let's go on to that right now. So for 7.2, the one thing that we actually, sorry, wrong one. So 7.2, where we left off was right here. When on a certain problem, I was actually talking about the shape, right? And remember what I did is I found NP is greater than or equal to 10. N times 1 minus P is greater or equal to 10. So what was the point in doing that? So let's talk about that. So that's called the normal approximation for the sample proportion. And P hat represents the sample proportion right there. Okay, so the normal approximation for P hat, which is the sample proportion. All right, sample proportion. So no problem. When the sample size is large enough for NP and N times 1 minus P to both be at least 10, the large counts condition, the sampling distribution of P hat is approximately normal. So that means when we have a large sample size, then what we do is just to confirm it, we multiply that sample size times the true proportion, and that same sample size times 1 minus that true proportion. This, of course, represents the successes, and this represents the failures. So when we have successes and failures that are at least 10, then we know the sampling distribution is approximately normal. In that case, we can use a normal distribution to estimate the probability of obtaining a simple random sample in which P hat lies in a specified interval of values. Okay. So in this case, obviously, it would work right here because we have N is 100 and we have P is 0.50. So 100 times 0.50 is 50. That's greater or equal to 10. And N times 1 minus P, or as I called it before, Q, right, is 1 minus P. So that's also going to be 100 times 0.50. That's also 50, which is greater or equal to 10. So we can say the sampling distribution is approximately normal. Okay, and so it has all of the attributes of a normal distribution. All right, so let's take a look at an example. A polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles of their home. Find the probability that the random sample of 1,500 students will give a result within 2 percentage points of the true value. All right, so right now, first of all, I'm going to define that my N is going to equal 1,500, 1,500, and my true proportion is 0.35. That again that's the probability that a student lives within 50 miles of his home. Okay, just to define that right there. So first of all, we have to figure out if the sampling distribution is approximately normal. All right, to do that, we're going to use the large count condition. Again, that's N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. So let's do it. 1,500 times 0.35. All right, so that's going to give me right there 1,500 times 0.35 gives me 525. So yes, that's greater than or equal to 10. Check right there. And then the other one is 1,500. 1 minus 0.35 is 0.65. Is 975. That is greater than or equal to 10. Check right there. So that we can say the sampling distribution is approximately normal right here. Okay. All right, next right here. So what we have to do now, secondly, is we have to find the mean of the sampling distribution, and we have to find the standard deviation of the sampling distribution. Recall, the mean of the sampling distribution is easy. That's just going to be whatever P is, which in this case is 0.35. Okay, that's not hard. Standard deviation of the sampling distribution. First of all, we have to confirm, does it pass the 10% condition? Okay, so that means that n has to be less than 0.10 of the population. N is 1,500. Is that less than 0.10 times all first-year students? That's all first-year college students in the entire world, as far as we know, right? All right. So in this case, yes, it does. Okay, so it does indeed. Let me get rid of this. So right here, so we're asking, does 1,500 less than 0.10 of all first-year college students? That's easily in the millions. So obviously, yes, it is. Okay. All right, so that means that we're going to go ahead and find the standard deviation of the sampling distribution. So remember, to do that, we're going to say the square root of p times 1 minus p over n. P is 0.35. 1 minus p is 0.65. N is right here, once again, 1,500. All right, so that's going to give you, let's see, the square root of 0.35 times 0.65. And then we're dividing that right there by 1,500. And that's 0.0123 rounded. There we go. Okay, so let me actually just put another slide up here so I have room. All right, no problem. Okay, so we have all that information right there. So we have the mean, we have the standard deviation right there. Okay, and now we're going to go and answer the problem. It says right here, find the probability that the random sample of 1,500 students will give a result within 2 percentage points of the true value. The true value is 0.35, right? So we want to know the probability that we'll give a sample right here. Remember, students will give a result, which is a sample proportion, within 2 percentage points of the true value. Okay, so if the true value is 0.35, 2 less than 0.35 is 0.33. And 2 greater than that is 0.37. Okay, so there we go. So to figure this out, we're going to go and just draw a little picture right here. We had, once again, that the mean is 0.35 and the standard deviation is 0.0123. All right, one standard deviation above is going to be 0.3623. And 0.35 minus 0.0123 gives me what? 0.3377? All right, there we go. So we're trying to find out from 0.33 to 0.37. So let's see here. 0.33 is about right here. 0.370 is about right there. Shade right in between there. There we go. There it is, right there. So we're going to say normal CDF. Lower is, once again, 0.33. Upper is going to be 0.37. Mean is going to be 0.35 right there. And the standard deviation is right there, 0.0123. All right, so we'll go and put that all in the calculator. So let's see if we go and do that. Remember, just go right here, run it. We'll say clear and then second distribution. And we're going to go to normal CDF. So we have right here, it's lower is 0.33. Upper is 0.37. Mean is 0.35. And standard deviation is 0.0123. There we go. And we have our answer is 0.8961 rounded, right? All right, let's make sure the question is answered, but I believe they just asked for find the probability that it's within 2 percentage points of the true value. So there we go. So the probability that it's within 0.33 to 0.37 is going to equal 0.8961. That's it. Okay, there's our answer right there. All right, so let's look at the book's answer. If they did anything different, I probably don't think they did. There you go. You got the mean, we got the standard deviation. Remember, 1,500 is less than 10% of all first-year college students. Right here, we found the large counts condition was true for both. So we said the distribution of p hat is approximately normal. All right, they made this little chart just like we did right there. All right, normal CDF, there we go, 0.8961, and that was our answer. Let's look at one more. Okay, in 2016, let me actually add another slide as well, just in case we need this for room right here. All right, in 2016, more than 200,000 students took the AP Statistics exam. Of these students, 14% earned the highest score of 5. So there's 14% of the students earned a 5, which is the highest score you can get. Find the probability that a random sample of 300 students who took the 2016 AP Statistics exam would indicate that 15% or higher score a 5. Okay, so they want to know in our sample of 300 students, what's the probability of those people in that sample? What's the probability that they got a 15? I'm sorry, that 15% of them or more got a 5 in our sample. All right, so no problem. So remember, first we start out right here. First, we want to see if it's if the sampling distribution is approximately normal. So we'll go to NP greater than or equal to 10. N times 1 minus P greater than or equal to 10. So we know that right here we have a sample of 300 right there. And we have P, which is right here, 14% right here, 0.14. So we'll say 300 times 0.14. And this is going to be 300 times 1 minus 0.14 is 0.86, all right? So 300 times 0.14 gives me 42. And that is indeed greater or equal to 10. And then we're going to have 300 times 0.86 gives me 258, which is also greater than or equal to 10. So we can say the sampling distribution of P hat is approximately normal. Okay, now we're going to find the mean and the standard deviation. So the mean of the sampling distribution, is just going to equal whatever P is. We already identified that as 0.14 because it's an unbiased estimator. For the standard deviation, remember we have to show the 10% condition is true. So N is right here, 300. Is that less than 10% of, this is more than 200,000? Let's see here. Oh, sorry. Okay, so let's see here. 10% of 200,000 is going to be 20,000. So yeah, 300 is way less than 20,000. So yes, all right, we're good right there. So we can go ahead and get the standard deviation. So that's going to be, remember, P times 1 minus P over N. So that's going to end up being right here. P is 0.14. 1 minus P is 0.86. N is, once again, it's 300. So 0.14 times 0.86 all over 300. And then take the square root of that right there. And we get right there 0.0200. Okay, I'll just say 0.02 right there. Is the standard deviation of the sample proportion. All right, very good. So we want the probability that the random sample of 300 students who took the exam would get a 15% or higher score. All right. So right here is word probability that, remember, that a random sample of 300 students who took the exam would indicate that 15% or higher scored a 5. So we want a sample proportion of 15% or higher, greater or equal to 0.15. No problem. So let's draw a little graph. All right, once again, right here, just to show what we had done before, remember our mean of the sample proportion, just a reminder, is 0.14. Our standard deviation of the sample proportion is 0.02. So we'll put the mean right there as 0.14. Standard deviation up 0.02 is 0.16. Down is 0.12. There we go. We're trying to find greater or equal to 0.15. So 0.15 is like right there. Greater than or equal to is right here. All right, we'll say normal CDF. Lower is going to be 0.15. Upper is going to be 10,000. Mean is going to be 0.14. And the standard deviation is 0.02. Okay, so let's go ahead and get that. So we have second, it's right there. Oops, sorry, second distribute. So let's try it again. There we go, normal CDF. And you don't have to worry that it's greater than or equal to. That doesn't make a difference in this case for the normal CDF in the calculator. So let's say 0.15. Upper is 10,000, or any really big number. Mean is 14. I'm sorry, I made a mistake right there. The mean is 0.14. My fault. That would have made a big difference. And no problem. And the standard deviation is 0.02. Okay, there we go. 0.3085 is my probability. So my probability is going to equal 0.3085. So about 30%. So 30, if we have a sample of, to answer the question, if right here, if you had to interpret, in this case you didn't right here, but if the probability that in a random sample of 300 students who took this 2016 AP exam, 15% or more would score a 5 is 0.3085. Okay. All right. So let's see how they had done it. All right. 300 less than 10% right here. That's the 10% gives you, we got the mean. We found the large counts condition right here. So it's showing the large count condition. It's approximately normal. So then they did 0.3085 and that's it. All right, guys, so we are done with chapter 7.2. Have a good day.